Good morning everyone. Today I will be presenting on natural units in the T0 model with a focus on energy as the base unit. This presentation explores how we can unify physical quantities by normalizing dimensionless constants to 1, creating a more elegant framework for understanding physics. Natural units matter for three key reasons. First, they simplify equations by eliminating conversion factors that often obscure the underlying physics. Second, they reveal fundamental relationships between physical quantities. And third, they allow us to focus on the physics rather than arbitrary measurement conventions. Traditional natural unit systems normalize dimensional constants like the reduced Planck constant, speed of light, and gravitational constant to 1. The T0 model takes this further by also normalizing dimensionless coupling constants. These include the fine structure constant, which is approximately 137.036 in SI units, Wien's constant of about 2.82, and the T0 parameter of roughly 0.008. I want to emphasize that 137.036 is not some mysterious or magical number as sometimes portrayed in popular science. It simply emerges from our choice of measurement units and in a properly unified system equals exactly 1. The conceptual foundation of the T0 model is that energy serves as the single base unit. All physical quantities can be expressed in terms of energy or its inverse. Mass, temperature, and frequency all have the dimension of energy, while length, time, and wavelength have the dimension of inverse energy. This leads to elegant dimensional relationships. Length equals inverse energy. Time equals inverse energy. Mass equals energy. Temperature equals energy. Wavelength equals inverse energy. And frequency equals energy. These relationships ensure dimensional consistency in fundamental equations. Einstein's E equals mc squared becomes simply E equals m, Planck's E equals h, nu becomes E equals nu. And the thermodynamic relation E equals kBT becomes E equals T. This dimensional simplification reveals the underlying unity of physical laws. The T0 model organizes constants into a hierarchical structure. At the foundation are dimensional constants all set to 1. These include the reduced Planck constant, speed of light, gravitational constant, and Boltzmann constant. Next are dimensionless constants also normalized to 1. The fine structure constant, Wien's constant, and the T0 parameter. From these, we derive various other constants. Vacuum permeability and permittivity both equal 1. The elementary charge becomes the square root of 4 pi, approximately 3.544. Planck length, Planck mass, and Planck energy all equal 1 by definition. This unified framework positions all constants in a hierarchical structure with energy as the fundamental unit, revealing their interconnections in a way that traditional unit systems obscure. The fine structure constant is traditionally expressed as E squared divided by 4 pi epsilon 0 h bar c, approximately 137.036 in SI units. It measures the strength of electromagnetic coupling and is often mischaracterized as a fundamental mystery of nature. In the T0 model, we set the fine structure constant to exactly 1. With h bar, c, and epsilon 0 already equal to 1, this means E squared equals 4 pi, making the elementary charge equal to the square root of 4 pi, approximately 3.544. This makes charge dimensionless and simplifies all electromagnetic equations. There's a physical interpretation of this normalization. The fine structure constant can also be expressed as the ratio of the classical electron radius to its Compton wavelength multiplied by 2 pi. In the T0 model, with both vacuum permeability and permittivity equal to 1, charge becomes a derived quantity rather than fundamental, simplifying our understanding of electromagnetism. The T0 parameter, beta t, governs the coupling of the intrinsic time field T of x in the model. It links microscopic and cosmological scales and has an SI value of approximately 0.008. In the T0 model, we normalize this parameter to exactly 1. The derivation of beta t comes from standard model parameters. It equals lambda h squared times v squared divided by 16 pi cubed, multiplied by the inverse of the Higgs mass squared and the inverse of 11. Here lambda h is the Higgs self-coupling of about 0.13, V is the Higgs vacuum expectation value of approximately 246 GeV, and mH is the Higgs mass of about 125 GeV. Setting beta T to 1 determines the value of 11 as approximately 1.33 times 10 to the negative 4. This 11 represents the ratio of the T0 length to the Planck length, showing how the model bridges quantum field theory and gravity. With our normalized constants, Maxwell's equations become dramatically simpler. Gauss's law becomes the divergence of E equals rho, with no epsilon 0. Ampere's law becomes the curl of B minus the partial derivative of E with respect to T equals J, with no mu 0. The other two equations remain unchanged. Quantum mechanical equations also simplify. The Schrödinger equation loses its h-bar. The uncertainty principle becomes delta E times delta T greater than or equal to 1/2. The wave-particle relationship becomes lambda equals 1 over p. For the hydrogen atom, energy levels become -1 over 2n squared. The T0 model equations show similar simplification. The intrinsic time field equals 1 over the maximum of mass or frequency. The gravitational potential becomes -m over r plus r, with no g. And the field equation becomes the Laplacian of the intrinsic time field approximately equals -ρ over the time field squared. These simplified equations reveal the underlying elegance of physical laws when expressed in natural units. The T0 model organizes length scales in a hierarchical, quantized way spanning 97 orders of magnitude. The Planck length serves as our base unit, equal to 1. The T0 length is approximately 1.33 times 10 to the negative 4, related to Higgs parameters. The Compton length of the electron is approximately 10 to the negative 23. The bow radius is about 2.9 times 10 to the negative 21. And the correlation length at the cosmic scale is roughly 10 to the positive 62. Between these stable scales are forbidden zones where stable structures generally do not exist. There is a major gap of about 19 orders of magnitude between the T0 length and the electron's Compton length, related to the mass ratio of the Higgs to the electron. Another gap of about 3 orders exists between the Compton length and bow radius, related to the fine structure constant. This quantization of scales resembles quantum mechanical orbital structure, suggesting a deeper organization to physical reality across all scales. The T0 model expresses all quantities in terms of energy or inverse energy, unifying length, time, and temperature dimensionally. Here are the key conversions. 1 meter corresponds to 197 MeV to the power of -1. 1 second corresponds to 6.58 times 10 to the negative 22 MeV to the power of -1. 1 kilogram corresponds to 5.61 times 10 to the positive 26 MeV. 1 Kelvin corresponds to 8.62 times 10 to the negative 5 eV. And 1 Coulomb corresponds to the square root of 4 pi divided by E. For practical examples, the proton mass is approximately 0.938 GeV. The electron mass is about 0.511 MeV. Room temperature is about 1/40th eV, corresponding to 25 degrees Celsius. 1 eV corresponds to about 11,605 Kelvin. And 1 GeV to the power of -1 corresponds to about 0.197 femtometers in length. These conversions help us translate between our familiar SI units and the more fundamental natural units of the T0 model. To conclude, the T0 model offers several conceptual advancements. Energy as the sole fundamental unit greatly simplifies physical laws. The fine structure constant value of 1,137 is not mystical but simply emerges from unit choices. Setting alpha em and beta t to 1 reveals a deeper unity in physics. And the result is physics described with minimal parameters and maximal clarity. There are profound philosophical implications. Dimensional analysis reveals connections previously hidden by arbitrary unit choices. A unified description naturally arises when constants take their natural values. Space and time emerge from the more fundamental intrinsic time field. And physical reality appears hierarchically organized in quantized scales. The practical benefits include simplified equations that make physics more transparent, clearer understanding of relationships between forces, a framework for connecting microscopic and macroscopic scales, and new perspectives on what we previously considered fundamental constants. Thank you for your attention. I'm happy to answer any questions about the natural unit system of the T0 model.